Okay, we're doing section 6, part 1. Use this equation to prove the following limit. We're going to try to prove this limit. To able to start this function, we gotta know where the restrictions of 0 is. Since cosine of x equals 0, we know -1 and 1 are one of the possibilities. Therefore, let's start with this. -1 of cosine of e to the x cubed greater or equal to 1. Now we have this section done. However, we're missing this root x. So we just have to multiply it all across. So we have negative root x of cosine of e to the x cubed greater or equal of x. Now we're missing one more variable, the limit. So now we have to multiply it all across. So we have the limit of x approaching 0 from the right of negative x greater or equal of the limit of x approaching 0 from the right of x root x of cosine of e to the x cubed greater or equal to the limit of x approaching 0 of x. Okay, now we can evaluate. When we plug in 0 in here, we get 0. However, we can't evaluate anything here yet, since we're doing squeeze by theorem. So we just have to evaluate the left and the right side of this. So we just leave this as that is. Cosine of e over x cubed greater or equal to 0. Since these two values are bound by 0, we can say the value of limit x approaching 0 from the right of root x cosine e over x cubed is bounded. Oh my god, I can't spell. Bounded between two zeros. Therefore, the value must equal to 0 by the squeeze theorem. That will be it. Thank you. Okay, we are doing problem 2 of section 6, page 10. So we have let f of x equals this function. What value must you assign to k that f of x is continuous at x equals 3? We gotta justify our answer. So something we gotta do first is look at this. Where would we get the function? So let's first evaluate with this. -3x minus k. The only reason we're doing this is it has two different values. We're going to find that x equals 3. So let's do that. This must equal to x squared. Since if this must be continuous, these two must be equal to each other. So there we go. And now we have to solve this. 3 of 3 minus k equals 2 of 3 squared. This will equal negative 9k equals 3. 2 times 9. Negative 9 minus k equals 18. Negative k equals negative 27. So, yeah. Oh, there you go. Okay, now we know what value k needs to be in this function. To just go over it, we have to make this continuous. Continuous at x equals 3. Since this is the only value of x that has it, we gotta make sure the top equals the bottom. Since at x equals 3, the second function would be continuous. However, the first function, because of k, it won't be continuous. Therefore, we gotta make k continuous. Therefore, we gotta solve for k. Okay, since we solve for k using algebra, we can now plug in the function. F of x equals, oh, that's a horror. Okay, let me redo that. Ooh, there we go. 3x plus 27. of 2x squared if x is greater than 3, if x is greater than equal greater. And we can prove this once more with the limits. The limit of x approaching 3 from the left of f of x equals the limit of x approaching 3 from the left of 2x, which equals 18. Yeah. And we can prove this again from the limit of x approaching 3 from the positive of f of x equals the limit of x approaching 3 of negative 3x plus 27, which equals 18 as well. Therefore, they're both equal. Because of f of 3 equals 2 of 3 squared, which is 18. Therefore, k can equal negative 27, which here will be positive since negative times negative. Since it's negative 3x minus 27, 3x plus 27. Hopefully that helps. Thank you. We're going to use the intermittent value theorem for f of x and g of x to see if it has one intersection in the value. So we know we're going to have to make f of x equals g of x. Let's do that. Negative 3x minus 2 equals x cubed minus 4x. Let's move everything to the left. So 3x minus 2 minus x cubed plus 4x equals 0. Now we can easily see we can combine these terms, 4 and 3. So we have negative x cubed minus plus 4, 5, 6, 7, 7x minus 2. There you go. Now we equal 0, and we let this equals h of x equals this. Now we have to find if the lower and upper bound of this interval. So let's let h of 2 equals, let's see, 2 cubed plus 7, 2 minus 2, 2, 4, 2, 4. So that would be 6. Negative 6 plus 14 minus 2. This goes 12 plus negative 6, and it's going to be 6. There we go. We have that. Now we have to find for h of 3. So let's do the same thing. H of 3 equals negative 3 cubed plus 7 times 3 minus 2. Let's go negative 27 plus 21 minus 2. 7, 8, 9. This will go negative 29 plus 21. This will give us negative 8. Since 9 minus 1 is 8. Equals negative 8. So we have 6 and negative 8 as the two variables. And since h of 2, since h of 2 is greater than 0 and h of 3 is less than 0, there must be a value. Since if we look this on a chart, 6, 4, 2, 0, 2, 4, 6, 8. We have negative 8 over here and 6. That means there must be a value of 0 in between these two variables. Okay, thank you.